Well, hello viewers. In this video, I will review yet another Edison Robot application called Train Station. So the agenda for this video is we will look at the project overview. Then we'll look at the prerequisites required by the viewers before they can benefit from this video. Then we will look at the working demonstration of the project. And finally, we will do a code review. So project overview. In this project, we will see Edison robots, which will be programmed as train stations, and another Edison programmed as a train. Pressing the button on a train station Edison robot will summon the robot Edison train to that station. 3 Edison robots will be used to represent the train stations, while a fourth one will be used to represent the train. And you can use many more Edison robots as train stations if you wish, or less, depending on your specific needs. The train will basically track the line, which is the standard line tracking program that you have on the Edison website. However, this is a variation on that to track the line only when the Edison robot is being summoned by a train station. And then when it reaches the train station, it's going to stop and wait for the next station. So for the prerequisites, viewers, it's better if they have working understanding of the Edison robot and they have programmed it before, specifically in Python. And this is a little bit more complicated program. This is heavy on the logic side of it and less on the mechanical or the physical structure side of it. It's also better if the users have done some infrared communication and line tracking using the Edison robot. And in the end, just be creative and come up with new ideas as you see how this program has been achieved and solution has been done for this program. So let's look at what the sample setup looks like. All right, so in this setup, we will have 3 Edison robots that will represent the stations. And then we will have 1 Edison robot that represents the train. So when we will press a triangle key on these station Edison robots, they will send a specific infrared signal, a specific one for each station to the train, and the train will register on its side that it has received a summon from a specific station, and it will start tracking the line. As it will start tracking the line, it will, when it reaches in front of that station, then the station will use the collision detection to detect that the train has arrived, and it will send a second signal to the train to notify it that it can stop and it can cancel the summon signal. So the train does not need to track that black line for that station anymore. The train is going to wait on that station for about like 3 or 5 seconds, and you can configure that. But if there are other stations which have also signaled to the train that they are also summoning the train, then the train will, after pausing for some time, then it will continue on its journey and start tracking the line until it reaches the other stations which have summoned the train. And again, the other stations will look at use the collision detection to detect that the train has arrived, and will send a second signal to the train to cancel the summon or the signal for that station. So each station will have its own signal or status telling the train whether it has summoned it or not, and each station will also cancel its own signal telling the station that it has already arrived, so it does not need to track the black line anymore for that station. However, if there are other stations, the train will continue its journey.
All right. For this demonstration, I have placed all the 4 Edison robots on this whiteboard. These 3 Edison robots facing outwards represent the train stations. So let me turn them on. So the 3 Edison robots are turned on at this point. Let me turn on this Edison robot representing the train as well. So now they are all on, but none of the train station has summoned the Edison robot. Now when I press the triangle key, that specific train station is going to send an infrared code to the train. The train Edison robot will register that code and it will start tracking the black line until it reaches that train station. When it reaches the train station, the station will use the collision detection to detect that the Edison robot has arrived, and it will send a second infrared signal to the train Edison robot that it needs to cancel that status and stop tracking the black line for that specific station, and the train will stop over there. However, if there are other stations that have also summoned the train, then this train Edison robot will start tracking the black line again, and we'll wait on that station for about like 3 seconds before it continues with the journey. It will only stop when there is no other train station which is still requiring it, or it has still summoned the train. So let's summon the train at this station. So as you can see, those 2 LED lights are being used for indication that the train is being summoned at that station, and when the train arrives at that station, the lights turn off. The collision detection tells that Edison robot that the train has arrived, and the infrared signal sent to the train tells it to stop, and it does not need to continue any more for that specific station. However, if there are other stations like so, then you will see that it is going to track the black line again until it reaches those stations. So first it's going to reach this station. Now it's going to stop there for like about 3 seconds. Then it's going to continue and until it reaches the last station. So the train is actually keeping a track of which station it still needs to go to, and it won't stop until it has reached all the stations which requested the train's presence. It's going to wait there for some time, and then it will finally come to the last station which has summoned the train. And that is the end of the demonstration.
Okay, so we are going to now do a code review for the train station program. There are basically 2 main categories, or 2 main types of program. One is for the train, and there are 3 programs, one for each station, with very slight variation. So if we look at the train station program for the first station, it's basically not doing much. It's just registering 2 event handlers, and in the event handlers, this one is detecting whether the user has pressed a triangle key. And this triangle key calls the call train event function that simply calls the train. So what it does, it sends infrared data 10 to the train which is received at the train. Then it also enables the object detection beam. This is used to see whether the train has arrived or not. And it also turns on the left and right LED. This tells myself that the user that this train station is waiting for the train to arrive. Then we have the second function, which is on the collision detection, which is train reached. So when it detects any obstacle and it detects that the train, any obstacle in front of it, which is essentially the train arriving right in front of that station, it turns off the obstacle detection beam off so that it won't send any more infrared data. Then it sends infrared data 20. So 10 is used to activate or enable or set the status in the train that the first station is requesting or summoning the train, and send data 20 is sent to the train and received at the train, telling the train that it can now cancel that status, and this station 1 is not summoning the train anymore. The train has fulfilled its obligation and it has arrived at that station. It also turns off the red and left LED, right and left LEDs, and then it tells me that this station is not expecting or is not expecting is not asking for the train to track and reach this station because it has already arrived and there has not been any new request. Similarly, for train station 2, similar to that, it's the only difference is that it sends the infrared data 30 for the train, summoning the train to station number 2, and infrared data 40, telling the train that it has received, so it can cancel that status and it does not need to go there anymore, or does not need to track the line anymore. However, if there are other stations, the train will continue, and we will shortly see how the train program operates. And the third one, again similar to the first two, the only difference is using send data 50 to tell the train that this train station number 33 is requesting or summoning the train, and then once the train reaches that station, it sends the data infrared data 60, telling the train to cancel its summon signals because the train has already arrived and it does not need to track the line anymore to reach this station. So these are the three stations, and obviously you can extend them to more stations as you wish. But the set of infrared data that you're sending, 50, 60, 70, 80, or 1, 2, 3, 4, 5, whatever you prefer, should be unique for each station and should not overlap. Okay, folks, so next look at the train program. So the train program, we're defining an array. This is an array of 3 stations. If you have more stations, you're going to define more members here. 3 is the number of stations, and each one is initialized with 0, which means that none of the station at the start is summoning the train. And drive is equal to 0. This is variable is going to be used to determine whether we need to move the train Edison robot forward or not. So this one will execute this loop and continuously executing it. So if drive is equal to 0, it will stop, which is the case right now. None of the station has summoned the train. However, if any one of the elements in this array is 1, it is going to set the drive equal to 1, and if the drive is equal to 1, then it's going to start driving. This is set in this event handler. So we'll look at that event handler, which is receiving the infrared data. So when the drive is equal to 1, it will then use this if else statement, and this is the standard line tracking. If it is on the white line, it will move a little bit left and keep moving it. If it is on the not on the white line, if it is on the dark line, like right, then it will keep moving a little bit right. And that's how it navigates the black line. And also turning on the right LED means turning off the right LED and turning on the left LED if it goes left. And then here I'm turning on the right LED and turning off the left LED if it goes right. Just an indication for myself to know which way the Edison robot is turning because it turns a little bit left and right and left and right, and that's how it tracks the light. Now, but where is this array set, which is initialized at 0, and then it's being checked over here, and if it is 0, if all these are 0, the Edison robot is not going to continue forward. So one of them at least has to be 1 in order for the Edison robot to go forward. Now, how it is set? So when Edison receives the data, which is this station event, and which is over here, it receives an infrared signal. What it does, it refers to those station and drive variable, and if it is so it receives the data over here, and if it is 10, then it's station 0 is the first one, and it plays the beep. This beep just lets me know that the Edison has received the data. If it is 30, means it's the second station, and if it is 50, means it's the third station. So it's respectively setting the station 0, station 1, or station 2, their variables to 1, representing that, yeah, this is the station which is summoning the train. If it receives 20, which is the pair, which is the next 10 and 20, which is from the first station, it then resets it to 0, and also sets a variable defined here called the stop. We'll see how the stop is working over here. Means that the Edison has reached the first station. This one means that the Edison has reached the second station, so it's a pair. It's the cancel for the second station, and this is the 60 is the cancel for the third station. So we set the stop equal to 1 in all 3 of them for the stop, and also set the station their respective arrays to 0, means that the signal for that station is 0, so that station is not summoning the Edison anymore. Correspondingly, if in the end we check if is it stop equal to 1, which means that it starts with 0, and if it is 1 in any of the cancelled events like 20, 40, and 60, these are cancelled events from the respective 3 stations, then it means drive equal to 0. It sets the global to 0, don't drive, and turn off the right LED, turn off the left LED, stop the drive, and wait for 3 seconds. After that, it will go back into the main loop and start executing it again, which means that now drive is 0, so it will not come here, and since drive is equal to 0, it's going to force it to stop if it has not stopped already. So just to check that maybe in the loop it may be in a position where it may start driving, so it forces it to stop, and then again checks the 3 stations. So at that point, if any of the station is still active, the Edison has not reached it, so drive will become 1, and it will start driving again. So that will happen if more than one station have set the drive to 1. So, and if Edison say reaches first station, it will stop and set that to 0, and it will stop at that station for 3 seconds, and it will set the drive to 0. Obviously it will not drive, but then when it comes back into this loop and this loop executes again, the station, for example, the first station is already not there, it's already reached there. Second station may be still summoning the Edison, so it will again the Edison train will again set the drive equal to 1, and Edison will keep driving again until it reaches the second station. So it keeps a track of all the stations, and as it receives the signal, sets their status to 1, indicating that it needs to reach that station. Once it reaches this station, then it's using infrared detection. It sets the status back to 0, means that the station is not summoning the Edison robot anymore, and it stops driving if there are no further station requesting the train. So that's the end of this train program. Thank you.